Hi everybody, it's Mr. Barbier. So this video is going to be brief because I want to just break down very quickly how to reduce fractions to lowest terms using the greatest common factor. So let's take a look at this. It says, an answer to any fraction problem is not complete until it is reduced to lowest terms, also known as simplest form. To do so, it is helpful to find the GCF, the greatest common factor. Step 1, list or think of all the factors of each number, top and bottom. When I say top and bottom, I mean the numerator and the denominator of a fraction. Step 2, find the highest factor that they have in common. Step 3, use this factor to divide both the top and bottom numbers of the fraction to reduce the fraction to lowest terms. Note, if you are having difficulty finding the GCF of two numbers, just use a small number like the number 2, for example, if both numbers are even to get started. Then keep dividing until you've reached lowest terms. So ladies and gentlemen, those are the steps, and now let's actually look at some problems. So we want to reduce each fraction to lowest terms using the GCF if you can find it. So number 1 says 6/8 equals blank. So what we want to do is we want to look at this fraction and say, all right, what number can divide into 6 and into 8 evenly without a remainder? Now let's talk about common mistakes for reducing fractions. A student might say to me, Mr. B, I'm going to use 3 to go into 6 and 4 to go into 8. Can I do that? Okay, the answer is no. You can't. When you're reducing a fraction, you must use the same number on the top and on the bottom. Okay, and the reason for that is because what I'm really doing is I'm really dividing 6/8 by a fraction that consists of the same numerator and denominator, meaning a number over itself, which is equal to 1, right? So if I'm dividing 6/8 by a fraction in which the numerator and denominator is the same, that means I'm dividing by 1, which means I'm not changing the value of the fraction. The value stays the same. Anytime you divide a number by 1, you get the same value back, right? Okay, another thing I want to break down is this, okay? So let's look at 6/8 visually. Let's look at it in terms of like a pie. So let's take a look at this really quick, all right? So I'm going to take this circle, which represents, for example, a pizza pie, and I'm going to split it into 8 equal parts. So that's 2 equal parts so far. Now that's 4 equal parts, right? Now we have 8 equal parts. Okay, so when we talk about a fraction, let's remember, it's always a part of a whole. That's what a fraction is. So we have a whole, and I divided the whole into 8 equal parts, which makes the denominator of my fraction 8, because there are 8 parts in total, right? So now if I write 8 over 8, right? 8 over 8, which means all 8 parts are being shaded out of 8, that's going to equal 1 whole because that's the entire pie. But let's look at 6 over 8. So I'm not shading all 8 slices. I'm only shading 6 out of the 8 slices. So let's take a look at what that's going to look like. So if I do that, right, if I'm shading this one, so that's 1, 2, 3, 4, 5, and 6. So this is a visual representation of 6/8. Yes? So let's get back to the actual problem and ask ourselves, well, if I want to reduce 6 over 8, how do I do it? What are the factors of 6? let's talk about that. The factors of 6, the numbers that multiply to give me 6. Let's do that off to the side real quick. So I have 6. All right, and there are different ways we can list the factors of 6. We can do so making a factor tree, right? Or we can do so in other ways. You know what? Let me use a factor tree. All right, so I'm going to put a little multiplication x right here because I want to list all of the factors of 6, the numbers that multiply to give me 6, right? So that's what I'm doing. I want to list all of the, let me put it right here. I want to list all of the factors. And whenever I list factors, I'm starting with the number 1. So 1 times what gives me 6? Okay, I just heard someone say Mr. B, that would be 6. You're right. After 1 comes the number 2, right? If I'm counting, right? If I'm counting like this, 1, 2, 3, 4, after 1 comes 2. So I'm going to put 2 right here. And 2 times what gives me 6? Okay, someone just said Mr. Barbier, that would be 3. Correct. Okay, because 2 3s is 6. Now, after the number 2 comes the number 3. But hold on a minute. Before I put the number 3 here, I have to ask myself, is 3 already in my factor tree? Well, 3 is already here. See? So if I put 3, imagine I did write 3. And I say, well, 3 times what is 6? It would be 3 times 2. But 3 times 2 is the same thing as 2 times 3. So I don't have to write, the same multiplication fact twice. So 1 times 6 is 6, 2 times 3 is 6. And ladies and gentlemen, all 4 of these numbers within my factor tree are factors of 6. Okay? These are all factors of 6. Okay? It's that simple. Now, let's look at factors of 8. All right? Let's do that too. So let me see. How about I just put them right here? Okay. And let me put my little multiplication x because I like to do that. All right, starting with the number 1, like we did before. 1 times what is 8? Okay, someone just told me 8. Very good. After 1 comes 2. 2 times what is 8? Someone just said 4. Very good. After 2 comes 3. But wait a minute. Be careful. Don't write 3 yet. You know why? Because is 3 times anything 8? No. So since 3 is not a factor of 8, I'm not going to write it in my factor tree. After 3 comes 4. But hold on a minute. If I put 4 here, look, 4 is already in my factor tree because 4 times 2 is 8. So since 2 times 4 and 4 times 2 are the same thing, I don't write it twice. So here's my factor tree for 8. Here's my factor tree for 6. Now here's the question I have for all of you. What is the greatest common factor of 6 and 8? Let me say it a different way. What is the highest number that you see in this factor tree and in this factor tree that these two numbers have in common? Someone just said, Mr. Barbier, that would be the number 2. You are correct. So 2, therefore, ladies and gentlemen, is my greatest common factor. Okay, so 2 would be the GCF. All right, there we have it. Now, folks, I'm breaking this down to you step by step, but once you master your multiplication tables, you won't really need to do this most of the time. All right, you will not, because it'll be in your mind. You'll already know, well, I know that 2 is a factor of 8, right? And I know that 2 is a factor of 6, right? I know that 2 goes into 8 and 2 goes into 6 evenly, right? And I know 4 can go into 8, but 4 can't go into 6 evenly, right? I know 3 can go into 6, but 3 is not a factor of 8. So 2 is my greatest common factor. Therefore, coming back to the problem here, I'm going to divide the numerator and denominator by 2. So I'm going to put here divide by 2. You do the same thing. Follow along with me. Divide by 2. Okay, remember we just finished saying that any number over itself is equal to 1, right? So I'm really dividing by 2 over 2 as a fraction. Okay, and now I'm going to say, well, what is 6 divided by 2? Someone just said 3. Very good. And what is 8 divided by 2? Someone just said 4. Very good. Okay, ladies and gentlemen, and the answer is 3/4. Now, I want you to see something real quick. Let's go back to our diagram. We said that this is a visual representation of 6/8, right? It's 8 slices, 8 equal slices, right? But total, but only 6 are shaded. What happens if I take the same pizza pie and instead of cutting it into 8 slices, I cut it into 4? Okay, now I want you to see something. You might say, Mr. B, what are we doing? What we're doing is we're taking this answer that we got 3/4, and we're going to make a visual representation, a diagram of 3/4. So I have 4 equal slices, and let's shade 3 of the 4 slices. So 1, 2, 3. Okay, we're all in agreement that this would be 3 out of 4, right? 4 pieces total, 3 are shaded. Now, ladies and gentlemen, take a look at something. What do you notice about this up here and this down there? Look at the shaded portions of each diagram. What do you notice? Do you see that this, right, portion of the circle is shaded, right? This entire, like, kind of a Pac-Man looking portion is shaded. And the same thing over here. Do you realize that visually, the same amount of pieces shaded here is the same amount that's shaded here, right? It's essentially 3/4, right? So these two are equivalent. The only difference is that this is cut into more pieces than this. So when we reduce a fraction, all we're doing is we're taking a fraction, and instead of it being a certain number of slices, we're cutting it into fewer slices. Here, we're cutting this pie into 8 slices, and I'm taking 6 out of the 8 slices. But here, I'm cutting the pie into 4 slices and taking 3 out of the 4 slices. But even though this pie is cut into 4 and this pie is cut into 8, and in this pie I'm taking 6 and in this pie I'm taking 3, you notice that you're getting the same amount of pizza, for example, right? If this is a pizza pie, right? 6 out of 8 slices of pizza is the same amount of pizza as 3 out of 4 slices of pizza. And that's what reducing fractions is all about. Okay? Equal fractions, right? We call them in math equivalent fractions, just cut into fewer pieces. All right. I wanted to break that down to you so that you understood conceptually what fractions are all about. Let's do a few more from the worksheet. So let's look at number 2. All right, now that we're kind of in a swing, let's kind of pick up the pace a little bit and say, okay, so we have 12 over 16. Think of the numbers that multiply to give you 12, starting with 1. Well, let's do it mentally, all right? So we have 1, right? Because 1 times 12 is 12. We have 2, because 2 times, you know what, as a matter of fact, let's do this. Let me show you something really quick. The other way to list factors. So another way to list factors is to do like what I learned was like a rainbow, right? So I'm going to write 1 and leave a space, big space, and write 12 over here. Okay? I want you to see something, right? 1 times 12 is 12. Okay? Now let's continue. Well, after 1 comes 2. 2 times what is 12? Someone said 6. Very good. So I'm going to put 6 over here and put a comma to separate it from the 12. Right, folks? And look at this, right? 2 times 6 is 12. What about after 2? Well, 3, right? But 3 times what gives you 12? Someone said 3 times 4. You're right. 3 times 4 is 12. And notice how there are no other numbers between 3 and 4, so therefore my factors are complete. All right, let's look at 16. What are the factors of 16? So we have 1, leave a big space, times 16 is 16, right? And you can make the rainbow either going above or below. This time, let's make it going below, just so that to give myself some room. So 1 times 16 is 16. Is 16 an even number? Yes, so that means 2 can go into 16. And 2 times what is 16? Someone just said 8. Put a comma to separate 8 from 16, okay? After 2 comes the number 3, but wait a minute, think about it. Can 3 go into 16 evenly? Let me see, 1 plus 6 is 7, right? That's the divisibility rule you learned in previous videos. So 7 is not in 3 times table, so nope, 3 can go into 16 evenly. What comes after 3? 4. Is 4 times anything 16? Someone just said, yeah, 4 times 4 is 16. Do we write 4 twice? No, we don't write 4 twice. When we list factors, we only write the number once. So I'm just going to put a comma here. So here are my factors of 16. So 1 times 16 is 16. 2 times 8 is 16. And because it's 4 times itself, I like to just circle 4 like this to indicate that it's 4 times 4. That gives me 16. So what are, or what is, I should say, the greatest common factor of 12 and 16? What do you think? Okay, someone just said, Mr. B, it's not 1. They're in common, but they're, that's like the smallest factor they have in common. Now you have 2, but there's one higher than that. You have 4, don't you? Right? We've got this 4, and we have this 4 right here. Okay? 4 is the greatest common factor. Therefore, I'm going to divide by 4, numerator and denominator. 4 goes into 12. What, somebody? Someone just said, well, 3 times 4 is 12, so it's going to be 3. And 4 goes into 16. Someone just said 4 times. Very good. Some of you are thinking, wait a minute, Mr. Barbier, hold on. Our answer for number 1 was 3/4. What's going on there? Just a coincidence. Okay, just a coincidence. That's all. Okay, and now what I'd like you to do is, here's the time for you to pause the video, like I like to do many times in my videos. I'm going to tell you, pause the video and try number 3 by yourself, and try number 4 by yourself. Okay, do so right now. Pause. I'm watching. Pause that video, and then unpause it when you have your answers for both 3 and 4. Do it right now. Okay, I'm going to assume that you did what I said and that you paused the video and you tried it. Okay, I hope you did try it. Now, ladies and gentlemen, I want to be very clear about something before I continue with 3 and 4. This is a way to work out the problem and find the GCF, as well as this, right? So factor trees, that's one way to do it if you need to. And this is another way to do it, what I call like the rainbow factor tree method. But once you have your multiplication tables down, and let's not forget our divisibility rules, right? From previous, let me show you something. Remember this? Our divisibility rules, yeah? This is also going to help you, okay? As a matter of fact, this will probably help you find the greatest common factor more efficiently, more quickly, as opposed to writing everything out, right? So let's remember our divisibility rules to help us reduce fractions. That's another purpose of the divisibility rules. It will help you to reduce fractions. So look at 30, look at 45, and ask yourself, what number can go into 30 and 45 evenly without a remainder? Okay, someone just said 2. Well, 2 can go into 30 because 30 is an even number, but can 2 go into 45? No, right? Try again. Okay, someone just said, well, what about 3, Mr. Barbier? Well, let's see. 3 does go into 30, right? We know that 10 times. And if we use our divisibility rule for 3, right, let's do it. 4 plus 5 is 9. 9 is in the 3 times table. Therefore, 45 can be divided by 3 evenly as well. So we could use 3 to divide into 30 and 45. However, my question to you is, would that be the greatest common factor? Keep going. Someone just said, Mr. Barbier, what about 5? Well, 5 can go into any number that ends in a 0 or 5, right? So yes, 5 can go into 30 evenly and into 45 evenly. But guess what? I'm going to challenge you to think even higher than that. Think. Let me see if someone figures it out. What is the GCF? Okay, someone just said, Mr. Barbier, wait a minute. I think it's 15? Let's try that. How many times does 15 go into 30? Right? If you add 15 and 15, what do you get? Oh, you do get 30, don't you? And you added 15 how many times? Twice? Okay, that's correct. Now, think about it. If 15 plus 15 is 30, if I add another 15 to 30, what do I get? Someone just said 45. Oh, so what does that mean? That means that 15 goes into 45 what? 3 times. There it is. Now, ladies and gentlemen, I know some of you are thinking, Mr. Barbier, I didn't use 15. I used 5, for example. Okay, that's fine. So if you divide 30 and 45 by 5, that is not wrong. That is okay. Let me show you this really quickly. Sorry. If you did that, that is a-okay. But I want you to see something. Okay? If we divide by 5, 5 goes into 30 how many times? Someone just said 6. Very good. And 5 into 45 how many times? 9. Very good. But look at 6 over 9 and say to yourself, wait a minute. 6 and 9, they have a common factor also, don't they? What can go into 6 and 9 evenly without a remainder? Somebody just said 3. That's right. That's right. Okay? And that's because if you look at your multiplication, if you're still shaky with it, look at the 3 times table, right? In the 3 times table, you have a 6 and a 9 as multiples of 3, which means 3 can divide into both of them. So 3 goes into 6 how many times, somebody? Someone just said 2. And 3 goes into 9 how many times? Someone just said 3. And notice I have the same answer that I got before. And you might be wondering, Mr. Barbier, wait a minute. What if I did it this way, but I still want to know what the greatest common factor is? Very easy. just take the two numbers you multiplied by. You divided by, excuse me. First we divided by 5. Then we divided by 3, right? And if I take 5 and I take 3 and I multiply them together, I get 15, which is my GCF. Okay, that's it. Let's see what people got for number 4. Again, I'm hoping that you did it right. If you paused the video and did it yourself. Okay, so someone just said to me, well, Mr. Barbier, you know what? I just used 2 because that's where I started with. That's okay. That's fine. If you use 2 to get the ball rolling, to get things started, I'm fine with that. Can we go higher than 2? Okay, someone just said, well, 3 can go into both. That's true. Go higher than that. Okay, someone just said 4 can go into both. You're right. As a matter of fact, let me show you something. Look, so we're looking at 24 and 36, right? So we know that 2 can go into it because they're both even numbers. And if we look at the 3 times table, right? Look, there's 24 and there's 36. Let's look at the 4 times table. Let's see, do we see 24? Yep. Do we see 36? Yes. So 4 is also a common factor of 24 and 36. Now the question is it the greatest common factor? Well, let's keep looking. What about 6? We have 24 right there because 6 times 4 is 24. And we have 36 because 6 times 6 is 36. So you think, there it is, I found it, there's a GCF. Wait a minute, can we go even higher than that? Keep looking, keep looking, keep looking, keep looking, keep looking. Wait, what about 12? Well, 12 times 2 is 24, and 12 times 3 is 36. So in this case, the greatest common factor is 12. Ladies and gentlemen, let's divide by 12. Okay. All right. And 2 times 12 is 24, and 3 times 12 is 36. My answer is 2/3. Okay. So ladies and gentlemen, I know for some of you this is difficult. I can sense it. But you know what? The more you study your times tables, the easier this becomes. So I'm going to leave number 5 and number 6 for you to do on your own. All right. Keep practicing, keep practicing, keep practicing. Reducing fractions is very important. All right. And remember, knowing your multiplication tables by heart would make this so much easier. So please study your times tables. Please study your times tables. It's very important, not just for fractions, but for everything we do moving forward. Okay, I'll see you in the next video. If you need any help, you know how to reach me. Take care and keep practicing, keep working hard. I'll see you next time.